Greetings and welcome, friends. Mr. Waddy here. We are on page 250. 250! Wow, that's crazy. And we've been talking about the elimination method. Eliminated, right? Elimination method for solving systems of linear equations. And we only did elimination method problems that had the first step done for us. The first step was basically get one of the pairs of your variables to have opposite coefficients, which notice these y's conveniently have opposite coefficients. Now you might be like, but Mr. Waddy, here, actually let me do a voice. Mr. Waddy, but doesn't positive 9 and negative 4 have opposites? And I'd say, yeah, 9 is positive, Jimmy, and 4 is negative. But those are not opposites because the absolute values of those numbers are not the same. So it would have to be like positive 9 and negative 9, or positive 4 and negative 4. So they're opposites in sign, but not opposites in magnitude or absolute value. So, so step 1 is done for us when using systems of equations elimination method. Step 2, this was interesting. We actually add the equations together. A bizarre twist, right? What? We've never done that before. And as long as our like terms and our equal signs are on top of each other, our constants are with each other, right? Then we're good to do that. So 9x plus negative 4x, all right, because I'm adding these, going to be, yeah, I saw that. Yeah, you got 5x, 5x. The y's, positive y and negative y, adds to be oi, or just 0, right? I don't even have to write it, which is what I wanted. Was eliminated. Elimination, right? And 2 plus negative 17 is negative 15. All right, so that was step 2 of the elimination method. Add your two equations together, eliminating one of the variables. Let's see, step 3, what did we do, Austin? You remember? Yeah, we're solving for x, which we're doing in this case by dividing both sides by 5. Correct. Correct. And I get x equals negative 3. All right, so there's half of my answer, right? Because I'm looking for an xy combination, which would represent the ordered pair, the intersection of those two lines. And what I would do now to find the y is I can plug this in for either equation's x. Yeah, I think the top one, like that, the second one's got like a negative 17. That seems scary to me. So I'm going to plug it in here. All right, so that's step 4. Plug your solution into one of the original. Doesn't matter which in this case. In substitution method, it did matter, okay? But in this case, either one. So pick the one that's easier for you. So plug it in and solve for the remaining variable. All right, so I'll have negative 27 plus y equal to dos. Add 27 to both sides. And I'll get y equals 29. So my solution is negative 3 comma positive 29. All right, good, 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 good. I just realized I've got to take attendance still for my in real life friends. Internet friends, you guys are all here, right? Yeah, you're all present. This video is, what's funny is this video will have like 2 views 3 years from now. But that's okay. Right, this isn't going to be one of my popular ones, but this one is the one that I made special just for you out there. I know one of you guys is going to be stuck on your homework with elimination method, and I'll be like, "Hey, I'm here. I'm here to help." I am here to help. Let's take a look at another problem. Internet friend, probably just one of you years from now. Who knows? Maybe this video will go viral. Could be. Let's see. Question 6. Step 1. Is done. Notice that I conveniently have opposite coefficients for the x's. So step 2, step dos, add them up. And negative x plus x is an aux, or just 0, or don't even write it. Y plus 3y is 4y, and that's equal to 4 plus 4, which is 8. Right, so I've got to have everything lined up in order to add it that way. Step 3, let's solve that variable. Divide both sides by 4. And my songs are going to sound so much better on this mic. One of my sons this morning was throwing a fit and crying. He was all mad that my wife took the dog out to go pee. So then, like, I grabbed a small guitar because obviously I have one, and then I was singing a song about Griffin's sad. Quieted him down. You plugged in for the bottom one. Actually, I like that because this one has a positive X. This one has a negative X. Yeah, I'm gonna take your suggestion. Good idea. I'm gonna plug it into the bottom one, but you could plug it into either and get the same. So X plus 3 times 2 equals 4. And let's see, X plus 6 equals 4. I have a feeling X is negative. X equals -2. Voila. Right? Not that bad. Not that bad. So I could write that as an ordered pair. Let's see. So that's going to be -2, comma 2. Right? So, last question that I'm going to look at today is 10. A lot of the evens today, but that's all right. Now, 10 is partially done. Where did 10 is partially step 1 done. Actually, not yet. Yeah, I've got to line them up into columns. All right. So I'm gonna work with this second equation. I'm gonna move that x to the other side. I'll subtract 3x. And actually, that'll be nice because that'll be the opposite of this positive 3x in a moment. All right, let's do that and see what happens. Okay, so I'll have -3x plus 7y minus 6 equals 0. Well, what I'm trying to do is to get all my terms here lined up underneath their friends. Actually, all right. Yeah, I've got to figure out what to do with these y's. I could actually bring this y to the other side since this y up here is on the other side. I'll do it, like, just because that's a little bit unusual for us. Let me show you how that would work out. But you could line it up however you want. If you want to write it in standard form every time or slope-intercept form, good, and you'll be fine. As long as they're both in the same setup. So let's see, so I'd have -3x plus, minus 6 equals -7y. So here's my new equation 2, right, is what I could call this. New equation, right? And let's bring equation 1, and I'll just write it back down here so that when I add them up, it'll be a little bit easier. All right, so I'm just going to rewrite equation 1. So I'll have 3x minus 30 equals y. And now step 1 is done. Notice I've got opposite coefficients for the x's, right? And I have my constants, I have my equals, and I have my y's all lined up in columns. So they're ready to add together. All right, and it doesn't matter that the constants are on this side of the equal sign. It doesn't matter that the y's are on that side. Done it either way. It doesn't matter. I could have brought everything to one side and then had it equal to 0, like I did here, but I felt that was weird. So step 2, add them up. And so if you set your columns up differently, that's fine. You'll still have the same answer in the end. So let's see, add these equations together. So -3x plus 3x is 0x's, which is 0, which is, I'll just leave that blank. And -6 plus -30 is -36. Bring down the equal sign. Like -6y is what I get there. Finding a -7 and a +1. And divide both sides by -6. I will get, flip it, wrong color. Y equals 6 positives. Positive 6. All right, so I've got half my answer. Now, I can plug this in here. I could plug it 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 in here, which I already wrote there. I could plug it into any of those to solve for x. It doesn't matter. as long as I've done the work correctly. Which y do you want to plug it in for? Which equation? This one's kind of almost solved for x. Like, I would just have to divide by 3. So I think I'm going to do that one. All right, it might not have the friendliest numbers, I don't know. But I'll plug it in there. Yeah, you can do any of those options. Oh, I always forget to write step 3. Step 3 was the step. Oh! Man, Austin with a save. We can plug it into any equation, but yeah, you're right. I gotta plug it in for y. Good save. Thank you, Austin. Yeah, if you guys are doubting what I'm saying, you need to speak up, because, right, I might be wrong. So let's see. 7 times, and instead of y, it's 6. Minus 6 equals 3x. And so I've plugged that in, and now we're going to solve for the x. So 7 times 6, what is that, 42? I always get confused on that one. Being honest, friend. 42 minus 6, that looks like 36. And how do I solve for that x? How do I get x by itself? Divide by 3. I'm going to get x equals 12. Like 36 divided by 3 is 12. So my solution is 12 comma 6. Right. Let's do a Desmos grapher on this one real quick. You guys finish writing that. Just so we can kind of like visually verify. So let's see. So my equations were, I'll bring my Desmos grapher up here. So my equations were, what are you doing here? 3x minus 30 equals y. So let's see, 3x minus 30 equals y. There's one equation. It's hiding over there, but it's there. Ah, lovely, lovely red line. And 7y minus 6 equals 3x. 7y minus 6 equals 3x. Let's see, and we see the intersection here is in fact at 12 comma 6. Let's also check one of our equations that we rearranged. All right, we rearranged negative 3x minus 6 equals negative 7y. Let's see if that works out. So we had negative 3x minus 6 equals negative 7y, sorry. Negative 7y. Hey, wait a minute, look at that. The green line and the blue line are the same line. So our rearranging that equation was perfectly fine. Right? You guys see that? Oh, it's what it's doing is solving this equation for x when there was no y, and it's saying that x would be 0.3 repeating. And then once I plug in a y, then it's like, oh, this is a graph that you didn't want me to solve for x. And so that's what it was doing there. Yeah. It's just a quick calculator. And let me also plug in y equals 6. What happened when I added those two equations together? Right, I got y equals 6. And notice that y equals 6 has the same intersection as the other lines. So being able to add those equations together is perfectly fine. I don't mind that it's a different line. What I cared about was the intersection. So adding those equations together like we did was a perfectly legitimate means to still find a solution for our system. All right, thank you for watching, Internet friends. Bye-bye.